Right here is the combination logic. Combination logic has inputs. You take this is your X input. It's okay. The combination logic as many you have to connect. It is not compulsion only one block which it will give you your result. Maybe one or multiple blocks you have to show. It's okay. Then later you have one memory block. You can show this is one memory block also. Whatever this combination block will take the X as the input and multiple gate okay circuit it executes and you have a result. That result should be stored in the memory block. It's okay. Then one more combination block you want, you can take that. I have one more combination block. One more combination block. It's okay. After one more combination block, are you taking only the memory output or you are taking once again from X? That is very much important. It's okay. When you are taking the memory block as the one more input, then when you are connecting this output to the feedback of the once again the logic circuit. It's okay. Take one example. You can leave the last block. You can concentrate only the first two blocks. You have a one combinational block. Combinational block is just gates you have added. Basic gates or universal gates or any decoders which you have used. Then you have given an input in the form of X. Then you have an output. Output is stored in memory block. Then sometimes what happens that memory block you have to feedback once again into the combinational block. I have given for this to the feedback. And memory block directly connected to the combinational block one more which it is next. I can show you the direction which it is next. Then this combinational block also includes the actual input. I can show the actual input. Now you see this final block, I can write this is the final block includes the memory state as well as the current input. It's okay, as well as the current input. Then what you have to say, its output, final output I can write. The final output will be dependent on, the final output will be dependent on memory block output as well as the current input. Now memory block output, what I am writing here, memory block output, I can write it as current state. And what I am writing X, current input. Now my output combination block or final combination block is dependent on these two. It's okay. Therefore, the output, final output is deciding by the memory block as well as the current input X. Then such models you can name it as a melay model. If suppose you have a combination block, then you have a memory block. Next, once again you have a combination block. That combination block is dependent on only memory, not for the current input X. Then such type of construction is Moore model. It's okay. How you can show the Moore model? You have one combination block. Then you have one memory block. Then you have one more combination block. It's okay. Now you see, if I am giving the input X here, and even this memory block can give a feedback to once again the combination block. But whatever the output, I can decide now based on the memory block only. See this second figure. First is combination block is there. Next is memory block is there. Combination block takes the input X, process it and store the result in the memory. And later this memory is once again you want to feedback to the first combination block, allowed. Then final memory what you got, can you apply to the once again the combination block, that is also allowed. Or you can take directly to the memory, that is also the final output. It's okay. Then the final output depends only the current state. only the current state, not to the, once again, the actual input you are supposed to consider. This actual output is there, no? Not necessarily you can consider after this combinational block. Even you can consider this also output. It depends how you have a design. How you have a design. But this combinational block is taking an input only from the memory block, not from actual input X. But see in the top figure, the conventional final block decides based on two inputs. One is the current state as well as the actual input. This is the actual difference between Millet model and the Murray model. Any doubt you have? Hello? Are you audible?
Yes, sir.
Do you have any confusion? Because we supposed to take this one only to continue. And some of the other differences are there. The differences are based on the number of blocks available, the number of hardwares included for that, how many inputs you have, based on that it is there. There is not much more difference for us.
Sir,
The final output is, hello?
use of doing it, sir. Why, sir?
Which one?
This one, sir.
These models,
No, sir. Sir.
Tell me.
Yeah, why we need to that output? We need to give another. Hello.
Good. See here. If suppose we have 3 members, it's okay. All you can call it as a hardwares. It's okay. A, B, C are the hardwares. If suppose I want to add for taking the first information in one memory, that is depending upon application. It's okay. I am giving you one example. Add 2 and 10. What is the result?
12.
12. That is came directly from your memory.
Yes, sir.
Am I right?
Yes, sir.
Okay. I want sum equal to 2 into 8 plus 5 into 6. 2 into 8 plus 5 into 6.
Yes, sir.
How many times you have stored this information in your memory?
6 times. 2
See,
into
2 and these all are inputs. 2, 8, 6, 5, 6 are inputs. And you have operators. 2 into 8.
Yes, sir.
16. You have stored in memory. 16 if you said that is stored in one memory.
Yes, sir.
Then 5 into 6, 30 stored in one memory.
Yes, sir.
It's okay. Now you have one more operator is there. You want to add that. Once again you have to fetch that. Fetch that means you have to take that. When you are taking that one, what you are doing? You are doing one process which it is add. That is one combinational block. Even after storing your information, it is not final for all the time, depending upon the application. First application I have given 2 plus 2, 4. You need not necessarily another hardware, combinational hardware. But second example, what I have given, there you have to process, store. Once again, you have to take that and process, store. That is depending upon multiple. This is not only, you can see here, this is not only 2 combinational blocks, as many blocks. This is not only one memory block, as many memory blocks. But the only example has to be given such a way that the output combination, final output combination is it actual input? First input is relating the final output, or first input is nowhere concerned to give the final output. Only based on these two it will differentiate. Clarified?
Okay, sir.
Melay machine changes the output based on the current input as well as the current state. That is present state. Current state is the present state. Melay machine will have some or fewer states of the compared to the Murray machine. That is the one. Output is placed on transition. See, when you want to take for the output, which it is to be placed on the particular transition. That is all time, because when you have given the particular transition, when to take the inputs and when to process that one and how to get the results, Based on that transition, you can possible to fix it in the melay machine. The output function is the function of the transition and changes when the input logic or the present state is done. See here, if suppose when you have given a t equal to 0 x, combination logic will take a t equal to 0, which it will give into the memory, that is t equal to t1 next clock. Then you want to store that in the next time, but when you want to take once again the input, that is one more time. This time interval, melay machine is executing based on the time intervals. And melay machine react faster to the inputs. How you say faster to the inputs? Finally, the logic block and whatever you have a current inputs, directly you can take it and to provide the output. But the synthesis when you went, procedural synthesis for an example when you went, melay machine, it's okay, it has a fewer states compared to the Murray state. And even hardware design, I can tell you, the hardware design for the melay machine will be less compared to the Murray. Later, for taking an example, you will come to know. And once again, a counter, you take counter. Counter is not a melay machine. How you are accepting a counter is not a melay machine? Counter is not a melay machine. At least you will come to know that. I want to count from 0 to 10. In decimal only you can start. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's okay. Are you adding the actual input for continuously till at the end? No. Are you writing the last output based on the present input? No. It's okay. Then on that case, what you can say, counter is not a melay machine. When the final output you want to write that time, actual input supposed to be needed, then you can say it will be a melay machine. And one thing, melay machine design is somewhat complex, because the actual hardware who is supposed to take it for all the time. It's okay. The actual hardware means the actual input supposed to consider till the last, which it will exist. But Murray model, it is not like that. Once you took first time the current input, the first hardware, it will complete that one. And whatever the information will be there, that it will be based on next the memory locations only. But the same when you are considering with Murray machine, output of the Murray machine only depends on its current state and not to the current output. It's okay. Here is the current state is memory, but current input is X. But output for the Murray model is not dependent on X. And number of states here it will be more. When you have an example, that I will come to know that Murray machine number of states will be always more than the melay model. The output is placed on transition. It's okay. Here also the output when you are taking from the particular memory, then every time memory getting data should be based on transition. I want to write the memory, I want to read the memory, will be based on only transition. It's okay. Particular edge. Transition meaning is particular edge. Rising edge I want to read, rising edge I want to write, rising edge I want to read, falling edge I want to write. That is left to you. And Murray hardware is required more because more hardware should be needed to the design for the Murray. The counter is a Murray machine. How you say counter is a Murray machine? 0 to 1. Next, I want to write 2. 2 depends on 1 only. What I am adding? 1 I am adding. Where you are adding 1? For the previous result only, not for the original result. After 2, 3. 3 after 4. 4 what you are adding? 1. 5. 5 what you are adding? Next data. Means the current input, whatever it is, I am not at all using for writing the final output. Only the current state, present input only I am concentrating. It's okay. After 8, I suppose to write 9. Then what you have added? 1 I have added. Which one you have added for 1? Present output. Which is present output? 8. Therefore, I got the 9. Is it relating to 1? No. It's okay. And design will be easy for the Murray model. And then what we have to do, knowing with this, we are supposed to take some examples. Then examples, when you take that one, you will come to know that is it a Moore model design and a Millet model design. It's okay. You go for one example. Copy one example. Design a synchronous counter using JK flip-flop 0120. See here. It needs somewhat more time. I may stop it in the meanwhile because 10:45 you supposed to connect for the next one. Whatever the part we have completing, we have to accept it and to continue in the next. Okay. Design a synchronous circuit. I can write here. Design synchronous circuit. Positive edge triggered JK. Positive edge triggered JK. It's okay. With minimal combinational output. With minimal combinational output gates to generate the following sequence. Following sequence. What is the sequence? 0 to 1 to 2, 2 to 0. X equal to if input you can write. If input x equal to 0 and 0 to 2 to 1 to 0, if x equal to 1. What is x? X is the actual input. When x is 0, the count should be 0, 1, 2, 0. If x equal to 1, count should be 0, 2, 1, 0. Have you understand the question first? Are you audible? Are you audible?
Yes, sir.
Okay. Now you have two options has to be given. The current input is x. When x is 0, your counter should count for 0, 1, 2, 0. When x equal to 1, your counter should be count from 0 to 1, 0. It's okay. Previous examples you have designed maybe mod 7, mod n, you can take an example. Maybe synchronous or asynchronous. Only example which it is included based on the problem statement. But here, the output you supposed to write based on actual input. It's okay. Now at least you will come to know that from reading the sequence, is it relating to the Moore concept or the Millet concept? Hello? When you are reading this problem statement, what is your conclusion? The output count will be based on x. X is the actual input. Actual input based the count will start. Then is belongs to Moore model or Millet model?
Melay model.
It is Millet model only.
Milay
Because x only decides. I can count for 0, 1, 2, 0 or 0, 2, 1, 0. Then what is x? Actual input. Then actual input is deciding by the final output. It's okay. Now what we have to do? We have to go for cell number, inputs, then present state, next state, flip-flop, and output you supposed to write. When you have a 0, 1, 2, 0, then number of flip-flops needed will be how many?
2.
2 flip-flops, 0, 1, 2, you can read. Is it possible? f of AB equal to 0, 1, 2, if I have written, can it possible to design? A 0, 1, 2, how many inputs exist? 2 or 3 or 1?
Three, sir.
Hello? Hello? Are you audible?
One input, sir.
How it is one input? One input can measure 0 and 1. How many inputs should be needed to go for 3-bit? A 2 to the power of 1 is how many? 2. Then inputs here are 0, 1 is there and 2 is there. One more 0 is there, you can leave it, at least 3 are there. In these 3, you should suppose to go for 2-bit. 2 to the power of 2 will be 4. You can go up to 3 because it starts always 0. It starts always 0. Then what I can do here, 0, 1, 2, you need a 2-bit of information. It's okay. 2-bit of information. Along with 1 is the actual input. Then I can write my inputs are, it's okay. This is one actual input. I can write. Then I have present state. Present state you have to write. Present state you can write it as A and B. And you have a actual input is, I can write A, actual input, X. Then this is cell number. Cell number is not much needed for us. You can write or not cell number. Now if how many total inputs are? One is actual input. Two are the present state. It's okay. That is QA and QB. A, B means you can write QA and QB. Otherwise you have a confusion. QA and QB. Now the input combinations you are supposed to take it as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. This is one block. Next block is 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Cell number will be 0, 1, 2, 3, 4, 5, 6, 7. 1 is the actual input, 2 are the present state, it's okay. Then you have total will be 3, 3 combinations will be 000 to 111. Cell number 0 to 7. Next state it will be very much important. Next state is very much important. See, to writing this one I can write it as next state. How next state I can write here? QA is written as QA plus, QB is written as QB plus. Now I can show here 002. 002. What is X here? What is X here?
0.
0.
0. Then first one you can consider. If X is 0, first one you can consider. From 0 to which is your count?
1.
1.
1. Then you write 0, 1. 0, 1. Next 1, 2.
2. 0.
2 is 1, 0. 2 representation is 1, 0. Next 2, 2.
3.
0.
0.
0.
0 is 0, 0. Next 3, 2.
Don't care.
Yesterday I have told this. 3, 2. Don't care. If it is not there, simply you write the don't care. Do you have any doubt here? Because one example will clear everything. Present state you know, actual input you know, actual input x0 cases you can take the count, then which one it can start first and what will be the next count? You have to fill up with the first present state to the next state. This box is okay?
Yes, sir.
Next x equal to 1 you see here. X equal to 1, what will be your count? 0. 0, 2.
2.
2 is there. Then 1, 2.
0.
0 is there. Then 2, 2.
1.
1. Then 3, 2.
Don't care.
Don't care. Do you have any doubt for the next step block? This one.
No, sir.
No. Next, what you do? Which flip-flop has as plus JK flip-flop? You use the flip-flop conditions based on the excitation. Excitation table you must to know. I told in the beginning only. All the flip-flops, function table and excitation table are so important. It's okay. Now I can write with the flip-flop inputs. Flip-flop inputs I can write. Which are the flip-flops you supposed to use? J, K, JB, KB. I can write this. QA to QA plus 0 0.
0 and don't care.
0 and
0 and
don't care.
0 to 1.
1 and don't care.
1 to 0.
Don't care and 1.
1 and don't care. You write don't care only.
Don't care. Don't.
When it comes to 1 to don't care or don't care to don't care or don't care to 1 or whatever it is 0. Don't care if it is. Directly you can write don't care. These two you can write the don't care. It's okay. Now you can go for 0 to 1.
1 and don't care.
1 don't care.
0 and 0.
0 and don't care.
0 don't care.
1 0.
Don't care 1.
1 and don't care.
Don't care.
Both are the don't cares. Similarly, you write QB. QB to QB plus you have to write 0 to 1.
1 and don't care.
1 to 0.
Don't care and 1.
Don't care 1.
0 to 0.
0 don't care.
Then this combination is don't care. Now you see. Can see the pen tip 0 to 0.
0 don't care.
1 0.
Don't care and 1.
Don't care 1.
0 1.
1 don't care.
1 don't.
1 don't care.
Don't care.
Don't care.
If you are strong in excitation table of which flip-flop you are using, next box it is easy to fill based on QA to QA plus, QB to QB plus. QA to QA plus I suppose to write JK, QB to QB plus I suppose to write JB, KB. Now you have this box. What should you write? Output you have to write. When you are writing the output, will get the output will be based on which one you suppose to write. This don't care you write directly, na? Need not necessary. Need not necessary when you have to write the output y. The y when you are taking with x equal to 0, the y when you are taking with x equal to 1, how should you have to write? How should you have to write? When you are taking with this y, based on the condition of the present outputs as well as taking with the current inputs. When you are writing that one, what will be the transitions you supposed to write it for A0, B0. Similarly, you have an X0 case. First one, cell 0. What will be the output? What will be the output? The output for the first condition when it will be 0 for writing into the equations, it's okay. Then when you are writing the equations for the output, when you are writing the output equations, that output equations when you have got will be x bar a plus b, taking with the conditions. That y one you can take it as f2 of x dot q, or f2 you can say it as x dot a dot q that you can write it into the x bar a plus b. Then in that case, when you are writing with the conditions, then what should be the actual output you have? That is x bar a plus b. X bar a plus b. When you are writing x bar a plus b, what should be the conditions from taking x, qa, qb? X is 0, a is 0, b is 0. What should be the final output?
0.
0. Then if x is 0, qa is 1, qb is 1. What should be the output? X bar a plus b. 1.
1.
Can write here y is equal to x bar a plus b. It's okay. When q will be a, b, and q plus will be a plus and q plus. When you are writing with the function f1, x with the q, when you are writing with the f1, x with q will be a and b. Then similarly for writing with the output x bar plus a into, a plus b. Then in these two cases you will get 1 here, because here either a or b will be 1, a plus b will be 1, x bar anyhow it will be 1 for the first block, because all the cases x will be 0. Then you can write this is 0, 1, 1, x. And what should be the output? Second box, I can write directly 0. Why is supposed to write 0? Sorry. X is 0. X is 1. Only decide. X is 1 in the second box. When x is 1, what is x bar?
0.
0. Then multiplying with any value, maybe 0 or 1, you will get 0. Directly what you have to do? You have to write the, it's okay, 0. Then what should you do? Taking with flip-flop output and the final output, you have a JA, KA, JB, KB put into the K-map cell. Then when you put into the K-map cell, immediately I can do next. What is JA? At least see the procedure this one and you will come to know that. I can write this is my X and this is QA, QB. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Now enter for the J. J, how it is there? See, entry should be very much important. Otherwise, you have a problem. 0, 0, 0. What is the value for J? 0. Next, 1. Next, you have a don't care. Don't care. See here. 0, 1, don't care, don't care. 1. Next, you have a 0. And you have a don't care. And it is in a sequence. It is in a sequence 0, 0, 0, 0, 0, 1 to 1, 1, 1. Therefore, I suppose to enter 0, 1, XX, 0, 1, XX, 1, 0, XX, 1, 0, XX. That is continuation. Then how you can make it to this group? This is 1 and this is 1. What is this?
X bar QB.
X bar QB. Good. What about this?
X QB. X QB bar.
X QB bar. Then I can write J. I can write here. J is equal to X bar QB plus X QB bar. I can write this is X XOR QB. Is it okay? A bar B plus A B bar. A bar B plus A B bar is A XOR B in that concept. Then what should be the second one? I can write this is first, and second one I can write with the X QA QB 0 1 0 0 0 1 1 1 1 0. What is the case you took? K. Then I can write here K equal to K. How it is there? XX 1X, XX 1X, then XX 1X same, XX 1X. What should be K?
1. QA QB bar.
No, 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 no. All are possible to group.
QA
Here.
sir.
No, 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 sorry. K equal to 1 is right. See, all the cells are either 1 or a 0. Is 0 is there? And if common 0 is there. Yes. Is there any 0 is there?
No, sir.
Then direct K to 1. K equal to 1. I can just circle this one. Then I can write the ZB. You can write ZB. To be 0, 0, 0, 1, 1, 0, 0, 1. What is the ZB? X0 X 1 X 0 X. Next 0 X 1 X X X. Tell me this one. How it will be? You can group this one 2. You can group this one 2. What is this group?
X bar QA bar.
X bar
QA bar.
QA bar. What is this one? X
XQA.
QA.
QA. I can write JB equal to directly X XNOR QB. X XNOR QB. What do you mean by that? A bar B bar plus AB. A bar B bar plus AB is A XOR B bar. A XOR B bar is A XNOR. Directly I can write here. JB you can write it as A bar B bar plus AB. A bar B bar plus AB is A XNOR B. X XNOR QB. Any doubt here? See, only 3-4 minutes I can conclude this. You're supposed to, which is next class?
ED.
ED sir.
Okay, I can complete. Next, JC. JC, how you have to do? You can go for JC. X 0 1 QA QB you can write 0 0 0 1 1 1 1 0. Entry will be, you can see here, entry how it is X1 XX. I can write here X1 XX. And what is the next? X1 XX, same.
Sir, it is
X1 X. Sorry,
You have to write JB.
no, sorry. This is KB.
Okay.
Should be KB. What is the value of KB?
1.
1.
1. Because all cells are either 1 or a don't care. Directly 1 you have to write. When you return this to 1, now what you have to do? You have to have a connections. It's okay. Fast I can connect here. How many flip-flops you have?
2.
How many flip-flops you have?
2, sir.
2 sir.
2 flip-flops. 2 bit means